Hello and welcome. In this tutorial, we will implement a dynamic slit-scan effect. So before we start patching, maybe we should clarify what we mean by slit-scan effect. So instead of showing the full frame at once, it captures just one slice and then moves on to the next slice in the next frame. So all the old slices stay there and the picture slowly builds up over time from all of these slices. So this tutorial roughly consists of 3 parts. The first one is creating a feedback system, because we are again working with feedback to achieve this effect. The second one is creating the slit-scan effect itself. And the third one is then getting creative with the algorithm and putting in a few twists to make it look more interesting. I am starting with an almost empty max patch. I already prepared a jit.world object as our rendering context. Here I have a jit.p window so we can see what we're doing. And I also prepared a video to put the effect on. Okay, let's start by creating the feedback system. I'm going to create 2 jit.gl texture objects. Let's make them full HD, so dimensions 1920 by 1080 at a depth 0, so nothing changes, and we will set the type to float 32, which is important when working with these kinds of feedback systems. So I need 2 of those. I can already plug our input video in here. Then I need the jit.gl.pix codebox object. When you're not working in Max 9, you can just use a jit.gl.pix object and then create the codebox within that object. Let's start by assigning our inputs. So I'll have the first one, call it pic in for picture in. This will be input 1. Then we also need a feedback in. Let's call this FB in. This is input 2. Then I will create our outputs. So out 1 is, for now we can just say this one is picture in, and out 2 can also be picture in. Then I can plug the input in here, which becomes then picture in and gets sent out here to our jit.world. So if I didn't make a mistake, this should already be working. Yes, looks good. And then this will be our feedback texture. So output 2 gets plugged in here. So now that we've set up our feedback system, we can move on to create the slit-scan effect. So how do we start? I want to create this effect by creating some kind of mask that tells our feedback system when to use a new slice, so to say, from the picture that's coming in or from the video that's coming in, and when to use the picture that is in our feedback loop. This probably sounds more complicated than it is, because what I want to do is essentially just create a black screen, which is representing the feedback that is coming in, and a white beam that is moving on the black screen, which is representing the input video that is coming in. And we then just use this as a mask or use this as a kind of control signal to tell our algorithm when to take this video and when to take this video here. So let's start by creating our beam. Let's first I will create a parameter and call it pos for position. Let's set this to 0. And Let's also assign it or connect it from the outside here so we can control our position. So then let's create our beam. How do we do this? So just for debugging, I will assign it to output 1. Then we can see nothing happens. We also get an error because we have to assign this. So to create this beam, I will use our normalized coordinates and only our X component. Only the Y component of it. So you can see represented on the Y axis, we have a gradient that goes from 0 to 1. Then to move our beam, we need to include our position, which is this one here. So let's see what happens when we move the position now. So you can see something is moving, but I don't just want it to move downwards and then disappear. I want it to wrap around. So to do this, I can use the wrap operator and tell it to wrap our values between 0 and 1. And now you can see it wraps around. So essentially what we're doing is we're adding an offset to our normalized coordinates and then we're wrapping the whole thing around in the ranges between 0 and 1. But this is not exactly what I wanted because I don't want this gradient. I want just a picture consisting of either black or white. So I want a fully white beam on a fully black background. So how can I do this? I can say, again, reassign it and say beam equals beam if it's greater than the size. So I also have to declare a size parameter up here. Let's just say this is 0.1 for now. And then I say here this is greater than size. And now we have kind of what we wanted, but it's the other way around. So this needs to change to smaller than. And now this is what we wanted. And now I can use this beam as a control texture or control signal and tell it, okay, every time a pixel is white, I want to assign it to the input that's coming in, and every time it's black, I just want to keep it in the feedback loop. So how can we do this? We can use our linear interpolation operator, which is called mix. But I think I will first create a new variable, call it color out. Okay, now we set color out to 1. Now we can start our linear interpolation. So again, we take the mix operator and now we have, okay, I already forgot. Let's for a moment set this here. Okay, we have the beam itself is white and the background is black. So every time this value is 0 or black, I want to use the feedback that's coming in, and every time it's white, I want to use the texture that's coming in. So I can use the mix operator and say black is the feedback. So first is the feedback, then we have the picture in, and then the beam is controlling this. So what this means is when this value is 0, we get this output, which is exactly what we want. When we have a black background, we want the feedback out. And when this value is 1, we get the input picture output, which is, controlled by the beam. So now we can see what's happening. we can only see the picture that's coming in because we didn't feed anything into the feedback yet, but when we're moving our beam, you can see that the picture within the beam is moving and everything else is staying. But I don't just want to control this with my mouse manually, so I will create a jit. What's it called? Time. And now we can see the Slit-Scan effect in all its glory. But I also want to be able to control the size, so I will create another message box here to control the size of our beam. So yeah, it doesn't make sense to go over 1 because then we're just updating the whole thing. But yeah, here you can see the smaller, the more stuttery it looks. And we can also change the speed of our position change here. And then we can see this funny dragging effect. Yeah, so I think this is the end of part 2. Now there are several ways to make this more interesting. I'll just get rid of this here. The first one that comes to mind is instead of using this jit.time object, which moves down very regularly, we can also change the position of our beam randomly. So for example, I can use a random object, put in 1000 here and then divide it by 1000. So what we will get out here is a float between 0 and 1. And every time we bang this one here, the position will change. So I can use a jit.bang object, press play here. Now you can see it's kind of stuttery random. It's even clearer when I reduce the size. What's also fun is to use the input picture to control certain parameters of our Slit-Scan effect. So we could, for example, how do we do this? We create a variable, call it control, and set it to our input picture. But I don't just want the whole thing. I just want the brightness of the input picture. So to do that, I can use the RGB to HSL function. So this gives me, from our RGB pixel values, we get the hue, saturation, and the brightness. And to get the brightness, we only need the Z component. And what do we do with that now? We could, for example, add the brightness of the input picture here. I will plug this back in here and let's see what's happening. Yeah, so you can see the movement is different for each pixel depending on the brightness that's coming in. We could also, just to see what it looks like, output our beam here. So yeah, this is the beam we're creating. So it's not just the beam that's going down, it's also depending on what's happening within the picture, I think. I mean, just this alone is a pretty cool effect. Yeah, and depending on how we're setting the values, I mean, this looks kind of, it goes kind of the direction of pixel sorting maybe, but also toon shader. So depending on how we set our parameters, this can look very interesting. Of course, we can also combine these two effects. So I don't like that. Maybe I should go down with the size. Yeah, no. Oh, sorry. This looks pretty fun. Yeah, so what we have here is essentially a modern twist on a pretty classic effect. I hope you found this useful, and thanks for watching.